Start.
Thought, huh? Right. Now I am going to give the video demonstration for the 11th program, which is called as Endpoint DFT. Endpoint DFT, I told you that it is already a non-real-time program. So once again, go for starting your Code Composer Studio. So first you connect it, as I told earlier, connect the target first. Go for debug connect and close the previous program that is already existing. Close the previous program. So the target is show the message display. Target is connected. So go for project new now. Okay, project new. So that you have to create a this one project named endpoint DFT underscore project, endpoint DFT dash project. This is your project name. Endpoint DSP dot project, and this is same, path is same, executable dot out is same. 67XX is the target for your this. Just click finish. So whenever you click finish, automatically a project named endpoint DFT under this dash project is there. So first and foremost thing is go for file new source file. Go for creating the source file. Go for file new source file. So and type your program here. You have to type your program here. So you have to remember that you need to display the real and imaginary parts here. Display the real and imaginary. Find a DFT of a sequence, then display the real and imaginary parts here. So this is your program for your this one endpoint DFT. So you can go through the logic afterwards. You are proficient with C language, so you can go through the logic afterwards for the this one endpoint DFT. There is some of the comment lines that are there. So green lines are the comment lines that are there. Right. So now after typing your source file, the next thing is go for file save as. Go for file save as. So save it as something dft.c, dft program.c. I am saving it as dft pgm.c. So dft pgm.c, this means that the file is being saved as dft pgm.c. Then immediately after saving this particular this one source file, the next thing is add this addition of the files. So go for add files to project. Okay. So where you have to save this? So if I go for file save as. So file save as. So in this you have to save. So such is my process, this is studio my project. So in this endpoint DFT and this is project, this is your project. So in this DFT program.c, save this with the extension. So add this files to the project. So DFT pgm.c. Now when you add this, automatically addition symbol will come and this DFT pgm.c is saved. Next is addition of library file. Go for this add files to project. So go for the path of the library file as earlier. CC Studio, C6000, CG Tools, LIB. So in this go for object and library files, CTS6700.lib, RTS6700. Whenever it is added, it will show the addition path. RTS6700.lib is being shown here. Next is once again go for adding the files. So go for CC Studio tutorial and the DSK6713. So in this go for hello1. So hello1, in this you go for linker command, selecting linker command file. So hello.cmd. So hello.cmd. So three files are being added. One is the source file, the second one is the library file, third one is the linker command file hello.cmd. So after addition of this particular three files, then go for this compiling, building and rebuilding your source file. So go for compile option first. Go for compiling. So whenever you compile a file, automatically 0 errors, 0 warnings will be displayed. Next go for building. Next one is, so building is for converting your source code into assembly code. Next go for once again rebuild. Go for rebuild. So whenever you rebuild that, this rebuild is complete, it will show this particular 0 errors and 0 warning, two warnings are there. Warnings not on a problem. Next go for file load program. Go for file load program. So you save this is go for debug. When you click debug, and the dot out file named having the same name of the project will come. So endpoint DFT dash project dot out, just add that. So now the program is added to the project. Go for running this one. So just maximize this so that you can view properly. So now you run, click run here. You can see here the real and imaginary parts are displayed in this particular thing. This is the real part of the sequence, 36 minus 4 minus 4 minus 4 etc. All the things are minus 4 approximately, 3.99 minus 3.99 etc. All the things are minus 4s are coming. Imaginary part is, first one is 0, second one is 1, 9.65, 8 something, all these things. Because you have given the sequence. What is the thing you have given the sequence? Here you have given the sequence or some sequence. According to that particular sequence, it will execute and save the files. Okay. What are the sequence in the program you have given? 1 2 3 4 5 6 7 8. You have given 1 2 3 4 5 6 7 8 as the sequence. So that will execute according to that particular thing. Okay. So we can change the sequence in the program. Okay. We can change the sequence in the program as some 6 ones followed by 2 zeros. Already we have worked out in your theory. 1 comma 1 comma 1 comma 1 comma 0 comma 0. So 6 ones followed by 2 zeros, you can do that. So once again you save this particular this one. So after saving this, once again you have to go for compiling, building and rebuilding. So compiling, building and rebuilding. So after compiling and building and rebuilding, once again go for file load program. So endpoint DFT underscore project dot out. So after that you go for, after loading the program inside the gate, you go for run option. You can see here the real and imaginary parts they are displayed. 36 minus 4 etc. All the 36, that is previous thing. Now the real part is 6 comma minus 0.707 1 okay comma 0 or 0.07 something. Imaginary parts are all these things, because imaginary part for the first one is 0 minus 1.7. That means how to interpret the sequence? You got to interpret the sequence as real part combining with, you have 6 plus j0, 6 minus 0.707 minus j 1.707, like that. Like this, in it, then next 1 minus j, like that. You can theoretically calculate using this particular thing, and then you can explain this particular this one. Theoretically you can calculate the samples using the flow graph, and then you can explain the, you can verify the calculations. For example, you need to view the 4-point DFT of the sequence. You need to change the numbers, okay, and then you have to view int of x is equal to 4, and then you need to modify that particular sequence, then view the 4-point DFT of the sequence. Okay, this is your non-real-time C program for doing the endpoint DFT. Okay, so endpoint DFT means how many points is going to generate? 8-point DFT. So it is going to generate 8 values, because the spectrum of DFT, you know the nature. The spectrum of DFT is discrete in nature, whereas the spectrum of DTFT is continuous in nature. Remember that the spectrum of DFT is always discrete in nature. Okay, the discrete spectrum will be there in observed. Okay, so that's why you are getting all the sample values here. Okay, that's why you are getting all the sample values. Okay, right. So this is about the program for computing the endpoint DFT of the sequence. Okay, so I told you that already. Give different samples and then try to explain this one. So here we can view the graph, graphically the samples also. You can view the graph. You can type this, go for graphically and view the samples also. For that you need to go for view graph time frequency. Okay, view graph time frequency, and then you need to display view this particular sample values. Okay, so here actually real and imaginary parts they are displayed as this one. So real of something is equal to some real, imaginary of something is given as some this one. So you can view those values. Okay, so this one is display type, is you can just select the display type and you can select the start address. Okay, suppose the start address is selected as real. Okay, start address is selected as real. Acquisition buffer size is 8. Okay, and display data size is 8. Okay, so here is 32-bit sign integer is there. So instead of 32-bit sign integer, you can go for 32-bit floating point, because it is a floating point is there. You can go for 32-bit floating point because it is a floating point, numbers are being displayed. Okay, so and afterwards we can go for status bar display on, and the magnitude display style is on, and the data class style is bar, because bar, whenever it is that, it will show the discrete time samples, show the discrete time signals. You can view OK. You can view all the samples. You can see real parts. You can view this 6 comma. Okay, next what is our next value? -1. Okay, -1, next +1, all these samples you can view. Okay, so 1 2 3 4 5 6 7 8. Okay, we can view all the samples that are coming out. Okay, so until this particular 0 1 2 3 4 5 6 7, so 7 samples you can view in this particular thing graphically. This is for the real parts. This is for the real parts. Next is imaginary parts. So this is the imaginary parts. You need to go for imaginary and then view the. So go for view graph time frequency. View graph time frequency. So just you can type here imaginary, you can type, and then press the variable, you can type it as imaginary and you can view the graph. Okay, 32-bit floating point you can view the graph. So go for imaginary. So you can now see the imaginary values here. You can now see the imaginary values that are displayed here. All this. Okay. Right. So this is your program for your DFT endpoint DFT of the sequence. Okay. So after this one, I've just said the program, just close this project. So if you do you wish to want to save it before closing the project? Click yes. So the project is closed. Okay. This is the procedure for your 11th program.